Lesson 11-1, the language of geometry. And in this lesson, you learn to identify points, lines, planes, rays, segments, angles, and parallel, perpendicular, and skew lines, and to classify angles as acute, right, or obtuse. Why is it important? Because understanding angles can help air traffic controllers determine airline flight paths. So let's take a look at this real-world application in construction. Students in Todd's Scholl's construction trades classes in Fairplay, Colorado don't just study, they put their learning into practice by building real houses. In fact, they built the town's Silver Hills Middle School, a four-classroom structure. So before construction of the building can begin, the corners of the building site must be level. A laser interferometer can determine the heights of the corners of the site with great accuracy. Okay? A laser is visible because the light is being reflected from particles in the air. So we can use ideas from construction of buildings to model geometric ideas. So let's take a look at what we will learn in this particular lesson. So each particle visible in the laser beam has a specific location in space and suggests that the idea of a geometric point. Definition of a point is a specific location in space with no size or shape. So a point can be represented by a dot and named with a capital letter. So these are examples of points. So this is point A and this is point B. Okay? So again, a point has no dimensions. Okay? And let's take a look at the definition of a line. So a laser beam travels in a straight path. In geometry, a straight path is called a line. A line is a collection of points that extends indefinitely in two directions. So arrowheads are used to show that a line has no endpoints. A line can be named with a single lowercase letter or by 2 points on the line. So you can name a line by a lowercase letter or 2 points on the line. So a point has no dimensions. A line has one dimension, which is length. Okay, so when you talk about the dimensions, you're talking about for a line, it is length. For a point, there is none. Okay, so these are examples of lines. This line is named with 2 points, line CD, and it can also be named by line L. The lowercase l indicates that. So this is line CD, or C and D in capital letters with a symbol of a line on top. Two arrowheads indicate a line, or line DC, the other way around. Okay, and line L. So these are all the names of possible names of that line. Okay. And if we look at this, think about it section here, can you measure a length of a line? Can you measure a line segment? So the first question is no. Okay. Can you measure the length of a line? The answer to that first question is no. Why? Because it has no endpoints. And since when you talk about a segment, we'll learn the definition of a segment. Okay, it will have endpoints. So the answer to that question would be yes. So let's take a look at the definition of a segment. Each wooden beam used in the construction of a building site is a model of a line segment. A line segment is part of a line containing two endpoints and all points between the endpoints. A line segment is named by its endpoints, and these are some examples of. This is an example of a segment. This is segment EF, and if you notice, okay, when you name a segment, you write the two capital letters, the two endpoints EF, and a segment on top. Notice the difference between the symbol of a segment and the symbol of a line. Symbol of a line has arrowheads. Symbol of a segment does not have arrowheads. So this can be symbol segment EF or segment FE. So to answer this question, can you measure a line segment? The answer is Yes, because it has endpoints. Okay, a line does not has does not have endpoints, so you cannot measure a line. Okay? Another definition, path of a laser beam as it begins at the generator and extends in one direction is a model of a ray. A ray is a portion of a line that extends from one point infinitely in one direction. Okay, so a line extends indefinitely in two directions. Okay, a ray, however, will extend indefinitely in only one direction. So a ray is named using the endpoint first and then any other endpoint on the ray. So this is an example of a ray. Okay, this is ray DF because you name it using the endpoint first. Okay, and any other point on that ray. So this is ray DF, and look at the symbol for the ray. Okay, it's a segment with one arrowhead on the right, very different from the symbol of a segment and different from symbol of a line. Okay, so let's take a look at example 1. Name 2 points, a line, 2 rays, and a line segment in the figure at the right. So we want to name 2 points, we want to name a line, we want to name 2 rays, and a line segment in the figure, okay, that we have there. So 2 points that we can probably name are points E and F. Okay, we can also name point G as another point. Okay, E and F will do. We can use also single lowercase letter, okay, or any two of the labeled points to name the line. So we can name it line EF, line EG, or line FG. Okay, we can also name it line M right there. Okay, so 2 rays that we can also name our ray FG and ray FE. Okay, and finally one of the line segments would be segment EG. Okay, another can be segment FG, another one can be segment FE. Okay, so let's move on. When 2 rays have the same endpoint, they form an angle. So the common endpoint is called the vertex of the angle, and the rays are called sides of the angle. So again, you have 2 rays which with the same endpoint. That's called an angle, and the endpoint is called the vertex. Okay, and the rays now are called the sides of your angle. So an angle is named using 3 points with the vertex as the middle letter. So if no other angle shares the same vertex, the angle is named with just the vertex letter or with a numeral. Okay? In this case, if you look at our angle there, this is angle ABC, or the symbol for an angle, which is this one, ABC. And if you notice, B is the vertex, which is always the middle letter, because the vertex should always be in the middle when you're naming an angle. This is also named angle CBA, okay, and the symbol of angle CBA, okay. So if there are no other angles there, okay, this is also called angle B, okay, or angle 1 right there. So different names for this angle. This is angle ABC, CBA, simply angle B, or angle 1. Okay? So the most common unit of measure for angles, okay, is the degree. A circle can be separated into 360 arcs of the same length. An angle that has a measurement of 1 degree if its vertex is at the center of the circle and its sides contain the endpoints of one of the 360 equal arcs. So this is an example of a degree, and there are 360 of them in a circle. Okay, and what we use to measure angles is what we call a protractor, and we study that in 6th grade as well. So let's take a look at an example how to use a protractor to measure angle PQR. Okay, so if this is angle PQR right here. Okay, So that's angle PQR, and let's read how to measure that angle. We want to place the protractor so that the center mark is at Q, right there. Okay, so the center mark of our angle is there at Q, and this is also the center mark of your protractor. Q is actually the vertex of angle PQR, and the straight edge aligns with ray QR. So the straight edge aligns with ray QR. Okay, use a scale that begins at 0 in QR. So when you find that ray that aligns with a straight edge, and look for the 0. Okay, read where ray QP on the other side of the angle crosses the scale. That's QP right there. Okay, the measure of angle PQR is 135 degrees, because if you read from the 0, you'll go all the way to 135 degrees. Using symbols, the measure, that's what M represents, measure of angle PQR is 135 degrees. Another way of measuring an angle can be this one. Let's say if okay, I think this is there. Let me get this, my protractor. I'm going to bring it down. We're going to show you another way of measuring it. Okay, so instead of measuring it from ray QR, I am going to measure my angle from ray QP. So let me make my angle smaller. There you go. There you go. That'll be good. Okay. So my angle now is smaller. I'm going to get my angle, and then instead of my straight edge being on QR, I'm going to put it on QP. Okay, and if you notice, that's in QP. Okay, and the 0 portion of my angle now, instead of the inside part, it's going to be on the outside part. So I read the outside scale of my protractor, and if you notice, it still falls on 135. So it doesn't really matter which ray you put a straight edge on. Okay, the measure of the angle will still be the same. Okay, and let's take a look at example number 3. And example number 3, not that one, right? This one right there. Name 2 points. Nope, not that one. This one. You can also use a protractor to draw an angle of a given measure. So let's say we want to draw an angle Y that measures 50 degrees. So what we want to do is we want to use a straight edge to draw a ray, and that's what we do first. So we draw a straight edge. Okay, after drawing a ray, place the protractor with the center mark at Y and the 0 mark aligned with the ray. So you are going to get your protractor, which I'm going to do right now. I'm going to get the protractor, and I am going to put that on Y, make my protractor smaller right there. Okay. Oops. Okay. And then place a protractor with center edge, mark at Y, and mark 0. Find the 0 mark aligned with the ray, and that's what we find here. So this is our ray. The 0 mark will be inside, and we want to find 50 degrees, which is step number 3. Use the scale that begins with 0 and find 50 and draw a dot. So from here, we find 50 and simply draw a dot. Okay, 40, 50, dot right there. Okay, so after drawing the dot, okay, we use a straight edge to draw the other side of the angle, angle Y, and that measures 50 degrees. So we take this out, and we're going to use a straight edge. In your case, you're going to use a ruler or something that's just straight. Okay, and then connect it to the vertex and make sure you connect it to that dot you just made. So this is now 50 degrees. So the measure of this angle would be 50 degrees. And now that's how you create a 50-degree angle. And that's exactly what happened in the book. Okay, 50 degree, exactly what we just did. Okay, and let's classify angles. You can classify angles by their degree measure. Acute angles have measures greater than 0 degrees and less than 90 degrees. Right angles have measures of exactly 90 degrees. Obtuse angles have measures greater than 90 but less than 180 degrees. And straight angles measure 180 degrees. Okay, so let's take a look at example number 4 and let's classify these angles. According to Ted Williams, one of baseball's greatest hitters, the best way to strike a baseball is at a right angle. So if you swing too early or too late, the ball will probably go foul. Classify each angle as acute, right, or obtuse. So if you look at this one, okay, the angle created by the bat, okay, is greater than 90 degrees, okay. So in letter A, if it's greater than 90 degrees but less than 180 degrees, okay, so the measure of angle JKL, angle JKL is greater than 90 degrees, so angle JKL is obtuse. The swing will be too early. Okay, that's definitely a foul ball. In letter B, it's exactly 90 degrees. The small square indicates that angle RST is a right angle. So if you see that small square, it indicates that it is a right angle. So the measure of angle RST is 90 degrees. So RST is right. Okay. And finally, the last part right here. Okay. A late swing. So the measure of angle DOT, okay, it's less than 90 degrees, okay, so the angle DOT is acute, the swing is too late, okay. Let's take a look at more examples or more definitions. The secret word for this particular lesson is Kyrie Irving. Secret name is Kyrie Irving. So the level building site described in the application on page 548 is a model of part of a plane. Definition of a plane is a flat surface with no edges. It has no boundaries. A plane can be named by a single uppercase script letter or using any 3 points on the plane. So this is your script letter, so we can name it plane. What kind of script letter is this? I'm assuming that's an S. Probably. So this can be plane S. The 3 points on the plane that we are going to use must not lie on the same line. That means they should not be collinear. Lines that lie in the same plane either intersect, okay, or are parallel. Okay? So before we go to that line, okay, let's take a look at the definition of that plane. Before we go to the definition here, when it says a plane has a flat surfaces with no edges or boundaries. But if you ask, oh, why do we have boundaries on this plane? The only reason is that we need to define what a plane is. But in reality, a plane will not have any edges and will not have any boundaries. Okay, it's actually infinite. This is just a symbol that it is a flat surface. Okay, and these are ways to name your plane. So this is plane AMF or plane S. So again, lines that lie in the same plane either intersect or are parallel to each other. So this is where definition goes. So lines L and line M intersect at point P. So that's what it means when they say intersect at point P. And there is no point of intersection of lines T and line N. Lines T and N are said to be parallel to each other. Using symbols, T is parallel to N, those two vertical lines next to each other indicate parallel symbol, which means T is parallel to N. Okay? Two lines that intersect to form a right angle are called perpendicular lines. Okay, so rays and segments can also be perpendicular. The symbol inverted T means is perpendicular to. Okay, so when you look at these examples, M is perpendicular to line N. Why? Because it forms a right angle where they intersect. Okay, same thing with this one. Segment RS is perpendicular to segment CD. Again, it forms a right angle. And lastly, you have two rays. You have two lines, two segments. Now two rays. Okay, they are perpendicular to each other because ray AD is perpendicular to ray AQ. And finally, the last piece of information that we need are what we call skew lines. So if two lines do not intersect and are not in the same plane, they are called skew lines. So the roof on the roof line along the front of the rectangular building and the line of the base of the side of the building, okay, are an example of skew lines. So this is a line right here, line AB and line DH. They are neither parallel nor do they intersect with each other. So if they neither intersect nor are they parallel and they're not in the same plane, remember the plane of AB will be this plane. The plane of AD will be in the bottom or probably the top. If they're not on the same plane, and they're neither parallel uh, nor do they intersect, they are called skew lines. Okay? So if you take a look at example number 5, identify each pair of line segments intersecting parallel or skew. So in A, segment EH and segment FG. Okay? So segment EH and segment FG, these segments are in the same plane, this particular plane right here. They do not intersect, so segment EH is parallel to segment FG. Okay. How about AE, segment AE and FG? Segment AE and FG, if you notice, okay, they do not intersect and they're not in the same plane. So AE and FG, segment AE and segment FG are skew. And finally, segment BC right here and segment CD. Okay, and if you notice, if this is a box, it will form a right angle right here, segment AD, BC and CD, it will form a right angle there. Okay, these segments are in the same plane and they intersect at point C. And if this is uh, a box, okay, that means they also segment DC is perpendicular to segment BC. But again, that's not part of the directions that we need to follow. It just says identify each pair of line segments as intersecting parallel or skew. Okay? And that's our lesson. Thank you for watching.